What's poppin', dogs? Mr. Allen here with some graphing of tangent and cotangent functions with transformations in this one here. We got a few transformations. It's going to be loads of fun. So let's get after it. Let's get it popping. First one here, we got y equals 3 tangent of theta minus pi over 2. So our period for tangent and cotangent functions is pi, okay? Since there's no multiplier there, it's just going to remain pi. That's how frequently it repeats. I, however, still like to scale it out like I normally would for a sine and cosine function. You don't have to do that. You can make this pi right here, but I usually like to show a couple periods. Otherwise, where's the fun in that? I want to do more points, man. All right, so I'm going to do pi over 2. We got pi. We've got 3 pi over 2. 2 pi. All right. And we'll go one more. We'll go 5 pi over 2. And we got negative pi over 2. I'm just gonna do it all. We're just gonna do it all. There we go. Beautiful. And we got ourselves, let's see here, 1, 2, 3, 4, negative 1, negative 2, negative 3. I'm not even gonna go down to negative 4. Okay. Lovely, lovely. Next up, we got our amplitude. As we know, can't do that with tangent and cotangent. They go on forever and ever and ever. Amplitude is how high and how low you go. And if we go to infinity and negative infinity, can't do it. All right. Phase shift. For this one, we do have to go to the right pi over 2. So right pi over 2. Our domain, range, we'll do that after we get the graph. I think it's easier with the picture there. I mean, range is going to be y equals all reals, but domain, I think we want to have that graph there. Okay. So everything's scaled out, ready to rock and roll. I'm going to go with a different color here now for our graph so it pops. All right. The math's got to pop. Okay. So let's see here. Our asymptotes for tangent normally would start at pi over 2 because we know that tangent of theta is equal to sine of theta over cosine of theta. And we know that cosine is 0 at pi over 2. Okay? So normally we'd have an asymptote here. But we've shifted to the right by pi over 2. So my asymptote will now be right here. And how frequently do our asymptotes show up? They show up every pi, which matches my period here. So I'm going to go over here to 2 pi. I'm going to go back over here, right on the y-axis there. Nice. And we can even put one right here if we really like. Just fill in the whole graph, man. Just a whole lot of stuff. A lot of fun stuff. Okay. So now, our tangent function. Well, if I plugged pi over 2 in, so if you're like still a little bit shady on this stuff, shaky on this, you could always plug in some values and kind of, math your way through this thing. If you're a transformations type of person, there's going to be a point right here. There's going to be one up here and down here, okay? But let's think through this, okay? So if I plug in pi over 2, okay, I'd get 0 in here, right? So that would give me the 0, that point right there. And that's going to happen for 3 pi over 2. It's going to happen here as well. Then the other thing we know about our tangent function is that to the right of that point, we'd get 1, and to the left of that, we'd get negative 1. So instead of 1, I'm going to get up here at 3. And if you don't believe me, check it out. This value right here is 3 pi over 4, right? It's between pi over 2 and pi. If I plug 3 pi over 4 in here, I'm going to get pi over 4. Okay, so I'm going to take 3 pi over 4 minus pi over 2, or 2 pi over 4. I'm going to get 1 pi over 4. Tangent of pi over 4 is 1, because the sine and the cosine are the same. And then 1 times 3 is 3. So you could table of values this thing to get your way through it. But usually if you get a handle on the transformations and what it looks like, you can just kind of transform your graph. And that's the more efficient way of going about it. So we're going to have another point right there, which will be at negative 3. And then we can do that for all of these here. We put those little sub points, if you will. Got one up there, one down here. We got a lot happening, man. Got one right here and here. So we're going to be down here and up here. Nice. Now let's go ahead and squiggle our way through these things, right? We're going to be approaching that asymptote, but it's really stretched out this time, right? So same here. It's kind of hard to do when it's so vertically stretched and make it look like it's curved, but do the best you can. Show a little bit of curvature to it, especially when you got not a whole lot of room here. Boom. That's good. All right, cool. So yeah, it should still have that S kind of a shape. I did better there than I did up here. But there we go. Points are important. This sort of S shape is good. This one's all right. Whatever. All right. Lovely. I'm going to give myself an A minus on the curvature. If I had more room up here, you know, I'm running out of room on the whiteboard. I got to get a bigger one, man. I got to make a bigger one, I guess. All right. Next thing here. Domain and range. So domain, range we already did. Domain is all about what x cannot equal with these situations when we have asymptotes. So x can't equal 0 here. Don't need to write that. But then it happens at pi, at 2 pi, at negative pi. So it's happening every pi. So x cannot equal pi n. N being some integer, some positive or negative integer, or 0, right, to get us all those asymptotes. You may notice that this number, or this, you know, pi, or whatever this multiplier will be, is going to match your period because the asymptotes are in accordance with that period spacing, okay? Cool, man. That was awesome. That was super dope. Tangent with those transformations. Now we have trace transformations. 3 transformations for cotangent here. All right. Period. I'm going to go with, I guess we'll go with green to get ourselves started here. You know, I'm going to go blue. I'm going to change it up. I'm going to change it up. All right, so for my period, I'm going to take pi and divide it by 1/2, which is the same as multiplying by the reciprocal. That loopy swoopy, that's official notation for multiply by the reciprocal. We're going to get ourselves 2 pi. That's my period now. However, I'm still going to scale it out just like this one to show you guys what's happening here. Because this is a horizontal stretch. And when we scale out these trig functions and we always kind of like pick the 4, cut it, you know, then they all look the same regardless of the transformation that's occurring. So I'm going to scale it out the exact same here, and we're going to see a bit of a difference, okay? So we got pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, negative pi over 2, and negative pi. I got 1, 2, 3, can't really get up there, negative 1, negative 2, negative 3, negative 4. Okay, cool. Amplitude, as we said, don't have it with these because it keeps going up, keeps going down. Phase shift. This is already in our factored form, which is wonderful. Okay, so we can identify our phase shift when it is in this factored form. We got the double parentheses there, right? We've got the multiplier taken out. That gave us our period of 2 pi. So for this one, we're going to go right by pi over 2. So right pi over 2. Kind of like the last one. Yep, exactly like the last one. All right, there we go. Nice. We'll deal with domain later, but range we know is y equals all reals. Okay, cool. So let's get some asymptotes going. Yeah, let's do it. I'll go with orange now. All right, we'll do a total color change. This is going to be fun. All right, so normally our asymptotes for cotangent, it started at x equals 0, right? That's our first asymptote. But now I'm shifting to the right, pi over 2. So pi over 2 is going to be my vertical asymptote. And if you don't remember which one's your asymptote, you could write like we did here, cotangent. Hopefully we can see this here, the whole thing. Cotangent is cosine over sine. So when cosine is 1 and sine is 0, right? That would be occurring at 0. It'd be undefined, which is why it normally would be at 0. But then our transformation shifts it to the right, pi over 2. All right? Now our period would be our spacing here, okay? So the next time I'd have an asymptote, normally it'd be every pi I'd get an asymptote, but now it's every 2 pi. So I'm going to go all the way over here to 5 pi over 2. And this would be like 1, 2, 3. Oh, man, it'd be over in here. It's going to be off the graph would be where my next one is. All right, so we'll mainly work with this area and a little bit of this guy right here, okay? So let's see here. The middle of this is going to end up being my point. Ooh, and I shift down 1. Oh, my goodness. I almost missed the shift down 1. So my middle here, I'll be moving down here. Boom. That is my starting point there, okay? Now, the other thing to remember with cotangent is it looks like it's like the flipped version of tangent, right? So I'm actually going to be, let's see, there's no multiplier up front here. So I'll just be back up 1 here at pi, and I'll be down 1 from that at negative 2 for 2 pi. And then we're going to have this sort of graph going on here. Let's see if I can do this. I feel like I'm going to mess it up. We're good. Okay. Nice. And the same will occur over here, right? We're going to be at this guy. We'll be down at this one right here. We'll be up. Oh, wait. Nope, I messed up. Pause. Pause. That was close. That was close. All right. So I'm going to be right over here. There we go. I'll be down at the -2. And then I'd be up here at the -pi. And I'll have the same sort of shaped graph going on here. And it would be approaching an asymptote that would exist right in here. Nice. All right. There we go. That's good stuff, man. That's good stuff. So as you can see here, now I'm taking up double the space. Normally it was just from pi to 2pi. Here I'm taking up a whole 2pi there, right? So that horizontal stretch, that 1/2, although it's weird to think like, why is 1/2 a horizontal stretch? It's saying it's going to take, it's going to move half as fast, right? So it's going to take twice as long to complete the full period, right? It's moving at half the speed, if you will, is the way that I often think of that, okay? So there we go. There's our lovely little cotangent. That's a lot. Okay, domain time. Let's do our domain. And I'm going to write my domain because it's a little crowded right there. We're going to go domain. Right in this little space that I got right here. So x cannot equal pi over 2. So we'll start with that. And then what's its spacing? It goes by 2 pi's, right? So plus 2 pi n. Or k or whatever. A lot of times people will use k or n as their numbers. But that's some integer, whether it's +1, +2, +3, or -1 or 0, right? Anything can be plugged in there for n. Any integer can be plugged in there for n, and it will give us each asymptote that we have. All right. Woo! It's a lot of graphing right there. A lot of fun stuff. A lot of dope things. Tangent, cotangent, often a little tricky because it's like that weird one that's not like all the others, right? But again, a lot of remembering some of these patterns that occur. If necessary, you can plug numbers in and evaluate and figure out what's going on based on unit circle values and what cotangent or what tangent equals here. So if needed, plug in values, but hopefully you can start seeing the pattern and then apply your transformations because I think that's the most efficient, quickest way to graph these things, and then you'll be able to actually finish your test. All right, that's about it. That's dope. You guys are dope. Stay awesome.